This video is a demonstration of the environmental monitoring system developed by Group NAT. In the top right corner, you see the DSL. It uses a batch size of 20 and a sample rate of 1000 milliseconds. The DSL has two sensors registered, one for an analog temperature sensor and one called simulation. Simulation is for a potentiometer used to simulate other types of sensors. The DSL is saved, which generates the corresponding code. The output C code is renamed to app main and transferred to the main folder for the ESP32. In the bottom left corner, we see the file getting built and flashed to the ESP32 using the ESP IDF framework. While the code is building, we showcase a Docker Compose with 3 containers running in the background. The Docker Compose includes a MQTT broker and 2 MQTT subscribers, 1 subscriber for each sensor type. Now the code has been built and flashed to the ESP32. In the bottom right corner, we use VS Code with a serial monitoring extension to execute the code on the ESP and monitor the output. As seen in the VS Code console, the ESP32 connects successfully to the Wi-Fi and starts collecting temperatures. The temperatures with label temp sensor is related to the analog temperature sensor, and the label sim sensor is related to the potentiometer. We are adjusting the potentiometer during the recording, which explains why the temperatures are changing so rapidly for the sim sensor. After a batch of 20 temperatures have been collected, the ESP32 posts the data to ThingSpeak. This can be seen from the Docker Compose output in the terminal. Notice that the analog temp1 container throws an error together with a response code of 429, while the analog sim1 container successfully transmits the data. The 429 response code is due to us using a free tier on ThingSpeak. This limits the amount of requests that we can send to the ThingSpeak bulk API to 1 request each 15 seconds. In the top left corner, we see the ThingSpeak dashboard. The left graph, called Field 1, displays data for the analog temperature sensor, and the right graph, called Field 2, displays the potentiometer data. It does not update immediately, and as seen in the video, we perform a manual refresh of the browser. This is our fault, and it is due to us cleaning the chart data before the recording. However, this change did unfortunately not reflect until doing the recording. After the data has been cleaned and both charts are empty, you can see the new data for the potentiometer getting displayed and updated in near real time in Field 2. Because the sim sensor keeps sending its data before the temperature sensor, the data from the temperature sensor keeps getting the 429 response code. As seen towards the end of the video, the temperature sensor manages to send its data before the sim sensor, and Field 1 on ThingSpeak is also updated. While the free tier does hurt our demonstration video due to the limited requests allowed, this would not happen had we used a paid tier. However, both of the sensors manage to send their data, and both Graph 1 and Graph 2 get updated during the video.